Let's start our lecture number 16 of matrices. So in this lecture, we will learn about this particular property that if A is any square matrix, then A plus A transpose is symmetric matrix. Now, why are we taking A to be a square matrix? We are taking A to be a square matrix because only then the transpose can be added. Okay, A plus A transpose will be defined. A plus A transpose will be defined only if A is a square matrix. Okay, if A is not a square matrix, then A plus A transpose will not be defined. That's why we are taking A to be a square matrix. Okay, so if A is any square matrix, then A plus A transpose is symmetric matrix. We have to prove this particular fact. So let us prove this. Okay, now A plus A whole transpose. In order to show that A plus A transpose is symmetric, in order to show that A plus A transpose is symmetric, in order to show that, we need to show that A plus A whole transpose is equal to A plus A transpose. Okay, if we show this particular thing, then we can certainly say that A plus A transpose is symmetric. So how to show this? Let us see how to show this. Okay, so A plus A transpose whole transpose. A plus A transpose whole transpose, complete transpose, is equal to A transpose plus A transpose transpose. Now, from where did this come from? From where did this come from? This came from here. A plus B whole transpose is equal to A transpose plus B transpose. A plus B whole transpose is equal to A transpose plus B transpose. From here it came. Okay. So A transpose and A transpose transpose. A transpose transpose A transpose. Okay. Now A transpose as it is written as it is, and A transpose transpose. A transpose is transpose. When we take transpose of transpose, we get the same matrix. So we will get matrix A. So since A transpose transpose is equal to A, so these two properties we have already learned in the previous lectures. This particular property and this particular property we have already learned in the previous lectures. Okay. So I am not going to teach you about that once again because we have already learned that in the previous lectures. Now A transpose plus A matrix. Now reverse the order. Okay, you already know that addition is commutative. Addition is commutative. What does it mean by addition is commutative? Addition is commutative means that we can change the order of addition without changing the result. If we change the order of addition, it holds good. Okay, so A transpose plus A, if we change the order of addition, what will happen? A plus A transpose. A transpose plus A will become A plus A transpose if we change the order of addition. Now have a look at this. Let us consider that A plus A transpose is equal to a matrix C. Let us consider that A plus A transpose is a matrix C. Then we have got the matrix C here. Okay. Now C transpose is equal to C. What does it mean by C transpose is equal to C? C transpose is equal to C implies that C is symmetric. C transpose is equal to C implies that C is symmetric. So, but C is equal to A plus A transpose. So A plus A transpose is symmetric matrix. In this way, we have successfully proved that A plus A transpose is symmetric matrix. But keep this thing in mind that this will hold. This will hold only when A will be a square matrix. Please keep this thing in mind. Keep this thing in mind that this particular property will hold only if A is a square matrix. If A is not a square matrix, then this property will not hold. Why? Why will it not hold? Because A plus A transpose will not be defined. Okay, A plus A transpose will not be defined in that case. Okay, so if the A plus A transpose will not be defined if A is not a square matrix. That's why. Okay, so keep this thing in mind.